Alright guys. Alright guys, hello. We're gonna do more Leetcode problems. Just gonna do one today. Most likely I'm gonna try and stick it to an hour. It might go a little bit more. But I'll be done by 6 today. Just because I got something else tonight to do. And I've done some other stuff already today, so I'll just stream some Leetcode. Yeah. My table looks empty because I haven't brought this keyboard onto the screen. Okay. We're going to do one monkey type and then we'll get started. Not bad. Back to Leetcode. Coin change. Okay. Coin change. You're given an integer array coins. Representing coins of different denomination, $1, $5. And an integer amount representing a target amount of money. Return the fewest number of coins that you need to make up the exact target amount. If it is possible to make up the amount, return. If it is impossible to make up the amount, return -1. You may assume return the fewest number of coins that you need to make up the exact amount. You may assume you have unlimited number of each coin. Amount 12. So I can see this in terms of a decision tree. Right. I can think of this as a decision tree where the number of coins have to add up to 12. And if it's a decision tree, you can create it into a top-down dynamic programming problem. And then from the top-down dynamic programming problem, you can make it bottom-up, probably. And then finally make this space optimized. So we're gonna try this in first recursive way. You have to return some I plus 1 and I plus 2. But for coin and coins, so for every coin you're going to check something. With a num plus coin, right, because these are all integers. If num plus coin is less than amount, then you DFS of num plus coin. I don't see why you need that. And if it's greater, if num equals amount, return 1, return ways ways is plus equaled 1, so is equal to 0. Return ways. Technically ways is 1 here. You return ways. If ways is 0, we're talking about ways of but you haven't done anything about the number of DFSs. Size, maybe? Size originally is 0. Size. Total. 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 Size. What am I looking at? Size plus 1. Size is equal to 0. Gonna return min So the size of coins we don't know. Okay. Amount is 11. Output is -1. Output is not even finished. Total equals amount. Yo, hello George Valen editor. How's it going, guys? Preparing for GRE. Damn. Gotta double check what GRE is. Is that not related to med? Or am I miss? Oh, I'm thinking of the GAMSAT. Not bad. I see, yeah, gotcha. Like the SAT for the undergrad, yeah. I see. Gotcha. Ways. How do I think about the ways? Yeah, damn it. 0. Why is if it's 0, So why is the ways 0? I'm actually confused. I see. Dumb. That was really dumb of me. What's your plan for AI dominant future where AI writes all the code? I don't know yet. I don't know how likely that'll happen, for one. But I feel like there's always going to be a job for us programmers, even if AI writes it. Don't know how to say much else. Hello, Kasahara. File too large, that's because we print this all the time. Hold up. W is not defined for sure. We just W equals DFS of 0, 0. Did you see the HackerRank article about how AI impacts hiring coding contests? No, I didn't. I'd be interested to know. Okay, code is too inefficient. How many test cases does it passes 0 of the test cases? Wait. Alright, it passes the 3 there, but it passes 0 of the ones in the actual problem. So I want to try also just running it here, because this is just a backtracking approach right now that I have. I'd be happy with 1 passing test case to know that I'm on the right track. Yep. Alright, 15, that's good. So now we can modify this so that it becomes a top-down dynamic programming problem. Perhaps. Except the problem is I don't know how that would look. So I might even look at the solutions now just because for the sake of time. Going to be a point after this where I'm rewriting the problems. But before I do that, yes, Aditya, I'll check it out. Check it out right now. HackerRank article AI impact hiring. I mean, they have a lot of AI related articles, it seems. Outcome CPU changes, primary coder, managing skills, consolidation. Deeply integrated across industries, increasing demand for developers who understand these technologies. See efficient gains leading to greater demand for target developers who can tackle new and complex challenges. The outdated notion that there's a fixed amount of work, known as the lump of labor fallacy, doesn't apply here. Lump of labor fallacy? What is that? Lump of labor is the mistaken belief that there is a fixed amount of work available in the economy and that increasing the number of workers decreases the amount of work available for everyone. Or vice versa. Okay, sure. Rethinking hiring practices. The rise of AI calls for a shift in how we hire developers. Companies need to move away from theoretical algorithmic style challenges. Okay. And focus on real world scenarios that reflect daily development tasks. I mean, fair. Right? So theoretical algorithmic style challenges are basically what we have at Leetcode, right? HackerRank's next-gen hiring approach does exactly this, leveraging code repositories that simulate real-world environments, help us better assess a candidate's ability to collaborate with AI, build features, and solve real issues. Going a step further and integrating AI assistance into these environments enables candidates to receive real-time coding support while still being challenged. Okay. So mirroring the AI augmented workplaces they'll join. Mirroring in the sense that you want to create a simulation for candidates to go through of what a day-to-day life is like at the company. I can kind of get that. That would be cool if you have something like that, not gonna lie. It would be good to have something like that. Definitely think it would be good to have something like that. Okay. It leverages code repositories to deliver real-world challenges in AI first world. To learn more about how we upgrade your hiring, download white paper or speak with an expert. What's the white paper? Wait, how do I download anything? I don't think I can download anything here on this page. That's alright. I get an idea, right? Simulations that are more like real world scenarios, real world coding contexts. Not a bad idea. It's just a matter of how you do that, right? Because I'm sure, this is a problem that Google has thought about, like, to the point where they've decided Leetcode was the best option, right? So is there a better option? That would be the question. Okay. Well, besides, let's have a look at some of these solutions. Potential solutions. So does this look similar to what I have here? Res infinity. DFS of some amount. If the amount is 0, then you return 0. But why would you return 0? For coin and coins, if amount minus coin is greater than or equal to 0, so there's still an amount left. The minimum of the result and 1 plus min coins so I'm gonna say that there is some slight differences. If I try and copy this and put this here, how many of the test cases would pass? Okay, so it is just the same amount, 15 out of 189. So that's good. That's a good first step, is what I did. Cool. Recursive technique doesn't entirely work here. T is the length of coins array. Wait, N is the length of the array coins. T is the given amount. Right, because worst case scenario, you could have depth of T. Yeah. Space complexity would be T being the number of coins. Yeah, I can see that. Okay, let's have a look at the actual problem on Leetcode YouTube. I solved the problem using backtracking, but it is too inefficient. Now I'm looking at the solution and seeing where to go from there to make a dynamic programming solution. Yeah, because I don't see exactly how it's done. Just thinking about it. Nafi tried out graph problems yesterday. Man, matrix traversal got me cooked. Yeah, not bad. Matrix traversal though, how would I remember it? How do I remember it as? I mean, if anything, it's like, you can kind of think about it for in terms of rows and columns. Yeah, anyway. Thinking about it in terms of rows and columns and thinking about the bounds were the tricky part for me.
Hey everyone, welcome back, and let's write some more Leetcode today. Today, let's solve another classic dynamic programming problem, coin change. And we get a pretty simple description. So we're given a list of coins of different values, and we're also given a total amount of money that we want to sum up to. But we want to use the fewest number of coins possible to make up or to sum up to that amount. And it's possible that that amount of money cannot be made up with any combination of the coins that we have, and then we want to return -1 if that's the case. And luckily for us, we're actually given an infinite number of each coin. So in the first example, we have coins of value 1, 2, and 5, and we have infinite quantities of these coins. The amount that we want to sum up to is 11, and basically, just look at this. What's the fewest number of coins we could do? Well, of course, we want to use a 5 because it's the biggest one. We can use another 5, and then we just need a 1 left if we want to sum up to 11. So in this case, you can see we only needed 3 coins. This is the fewest number of coins we needed, so we can return 3. In the second example, we have a coin of value 2, but we want to sum up to 3. We can try 2 plus 2, but we know that's 4.
Okay,
so
greedy
we went
doesn't
over
work.
3, so there's no way to
DFS,
possibly sum up to 3.
then DP.
So we return -1. There's no possible
Yeah,
solution.
sure.
So your first...
Alright. I forgot to ask you last time, but how did you go on your exam? Did those 12-hour study sessions pay off? Yeah, they went alright, you know. I think they paid off. For me, at least. The mark that I got was pretty satisfactory. And it was better than my first semester. Alright, for context, I guess. You know, I've only done 2 semesters of my master's so far. But the first semester of my master's, we had a number as our WAM, and we got it up by, I don't know how many points, but say they on average increased by 10 points for each subject, or 10% for each subject. So I would say that is a plus. That is a good for me.
Idea might be, can we just be greedy? Is the problem
By doing the streams, that is.
Can we just be greedy? And let's look at this example. So let's say these are our coins 1, 3, 4, 5, and we want to sum up to 7. So when I say greedy, I mean, okay, we want to sum up to 7. Let's just start at the biggest coin we have. So let's start at 5. So now let's look at the biggest coin again, 5. If we add a 5 here, we know we're going over the total amount 7, right? So we don't add another 5. Well, let's look at the 4. Well, we know
right, so this is what greedy means.
Going to be more than 7. 5 plus 3 is going to be more than 7. Okay, but we found a 1. Luckily, we have a 1. So let's add 1 to it. Now we're at 6. So let's add a second 1. Now we got to the sum 7. So we basically went down.
I see what you mean by greedy.
Biggest, smallest coin values, right? That's what I mean when I say greedy. Let's pick the biggest one possible first. So notice that this took us 3 coin values, right? So our result in this case would be 3. But is that the minimum amount of coins? The answer is no, because, you know, just looking at it, we can tell we got a 3 and we have a 4. 3 plus 4 is 7. That means the minimum amount of coins is actually 2. So this is a counterexample. We cannot be greedy if we want to solve it. So the next thing you might try.
But it is not the solvable method. See example of 1. So 1. 2, 1, 3, 4, 5 with 7 as target. How does masters work? I've heard that some need people to write a thesis and others do a project. What does your masters require of you? So I can do either at the moment. Because my master's is a coursework master's, I can pick between doing my research project or a software project. So in a sense, when you do the research project, that's where your thesis is. You have to write a dissertation. Now, I don't know what is exactly required of a dissertation, but I am inclined to go down this research route for a semester, do that research subject and see how it goes. And we'll see. Maybe I decide I want to do the software project instead. But right now, I'm set on the research project, and that'll happen next semester, or either next semester or the semester after. And then after I've done that, that'll be done for my master's. Yeah.
is like a brute force solution, right? So to do the brute force solution, we need to implement some kind of depth first search or backtracking solution, right? So let's look at the same example, 1, 3, 4, 5, and amount sum to 7. So what would a backtracking solution even look like for this problem? Well, it's going to be brute force, right? So we have 4 coin values. So that means in our decision tree, we have 4 possible choices. We can choose a 1, we can choose a 3, we can choose a 4, or we can choose a 5. In this case, the remaining amount would be 6 because 7 minus 1 is 6. In this case, the remaining amount that we have to compute would be 4 because we're taking 7 minus 3, which is the coin that we chose. So we get 4 as the remaining amount, right? In this case, we would have a 3, and in this case, we would have a remaining amount of 2. So since none of these are 0, once we get to 0, we know that we've computed the total amount that we want. But right now, we have to continue going, right? We have to continue doing the brute force approach. Let's start at this side right now.
It's the sub-problems.
So we still have 4 coins, right? We have unlimited quantities, so we can choose the coin 1, we can choose a 3, we can choose a 4, or we can choose a 5. If we choose a 1, we'll have a remaining amount of 1. If we choose a 3, we're going to get a negative 1. What does that tell us? That tells us if we chose a 5 coin and we chose a 3 coin, then we get to a negative value. That means 5 plus 3 cannot be the amount, so we don't have to keep searching here. We can stop, right? We got to a negative value. If we keep adding values to it, it's just going to become more and more negative, right? And you can probably notice that since these values are even greater, 2 minus 4 is going to be negative 2, 2 minus 5 is going to be negative 3. So we can't go down these paths either. We don't have to search them anymore. And so now here we're going to see, okay, we can choose a 1 coin. Of course, we can choose a 3, 4, and 5, but we can see from here that that's not going to work. That's going to lead us to a negative value anyway. If we choose a 1 over here, then we know we're going to finally get to a 0. So this is what we want, right? We took a 5 from up here, we took a 1 from over here, and we took a third one, right? So then if we count how many coins we chose down this path, we know we get 3 coins, right? And we get to a 0, so of course we don't have to keep searching anymore. So we found one possible way where we can sum up to the amount 7. We know it has 3 coins, which, you know, from the previous example, we know that that's not the minimum amount of coins, but we found an algorithm that at least tells us a possible solution. So we
If you have like multiple sub-problems, if you have a 3 and then you make it -1, you get a 2. The sub-problem of 2 was you'd get a 1 and a 1. So 3, 1, and a 1 and a 1 would give you 3, 1, 1 and a 1. Wait. 3, 1, 2. Can you ever reuse? You can't. You can't really reuse it, can you? Interesting. So what can you reuse?
Some coins we can set to 3. So now I'm going to show you what happens when we go down this tree path, even though we know that the solution is actually 3 plus 4, which is 2 coins, which either of these is going to get us to the correct solution. I'm going to show you what happens when we go down this one anyway. So we can choose a coin 1, 3, 4, or 5. So if we go down this path, we will have a remaining amount of 5. Here we'll have a remaining amount of 3. Here we'll have a remaining amount of 2. Here we'll have a remaining amount of 1. Do you kind of see how we're taking the original problem, which is 7, and then breaking it down into sub-problems like 6, and then breaking it down even further into 5? And not only that, we have sub-problems, yes, but do you also see that these sub-problems are repeating themselves? Here,
That's what I'm thinking, right? It is repeating itself, right? At 5, the smallest that you can get is at 7, at 2, at 1. At 1, the smallest you can get is 1. That'd be your result. The smallest you can get at 2 is 1. The smallest you can get at 2 is 2. By counting the number of values there. The smallest you can get at 3, I haven't found.
here we have a remaining amount of 1. Here we also have a remaining amount of 1. So do we even have to compute this path?
No.
Because we already know if we have an amount 1, it takes only a single coin for us to be able to reduce it to the amount 0, which is what we're looking for. So since this subproblem repeats, I don't have to compute it. I can just borrow from over here. So in that case, we see the same thing happen though. We use a coin 1 and we get 0, and we see that, okay, it took 3 coins for us to get to 0, right? We took a 1, a 5, and another 1 from over here. So basically we got the same thing that happened over here, just in a different order. And just to make this a little less messy, I'm just going to tell you that none of these are going to lead us to the optimal solution. So now let's look at this case. We have a remaining amount of 4. How many coins does it take for us to get an amount 4? Well, let's brute force it. Let's check every possible combination. Here we'll get a 1. Here we'll get the value we're looking for, 0. That's great, but let's just look at this last one. With 5, we'll get a -1, meaning we can stop searching. So this is awesome. We got a 0, and let's count. How many coins did it take us to get to this 0?
2.
We took 1, 4, and we took a 3. So this path is only 2 coins long. We see our minimum is currently 3, but we can actually replace this now with a 2, because 2 is the minimum number of coins needed to total to amount 7. So we know this is the correct answer, but let's just see what happens with the remaining stuff. So first, let me just look at this 1. We see we actually already solved this subproblem over here, so we don't really need to solve it again. We know it takes 1 coin for us to go from 1 to 0.
For sure.
And what about this 3? Okay, well, we can do the same thing, right? 1, 3, 4, 5. And I'll just tell you, from here, we're not going to find the optimal solution. Going from 4 to 3 and more, that's going to obviously be more than the current minimum of coins that we have, which is 2 right now. So this is not going to lead us to the correct solution. But you see that once we compute this stuff, Then we have one last subtree
Yes.
over here, right? This original 3. But once we already solved the subproblems of this, do we really have to solve the subproblems here?
No.
If we store it in memory, if we have like a cache, or you can call it DP, we do not have to repeat these subproblems.
DB.
So the way I just solved this was called
Dynamic.
top-down
or
top-down memoization.
Okay.
Because we're doing it recursively. But
Top-down
you can actually solve
memoization.
this with a true dynamic programming solution, which is bottom-up.
Bottom
It
up.
means exactly what it says. So bottom-up. Basically, instead of solving the original problem,
You do
where the
for
amount
loops.
is 7, we solve it in reverse order. We start at the smallest one, which is 0, right? This 0 over here. So we want to know what
I see, yeah.
the minimum number of coins.
I
We can call
can
it
get that.
DP of 0. So for amount equals 0, what's the minimum number of coins for us to sum to 0? Well,
Okay, well, here is the catch. We're gonna rearrange this DP or DFS so that it returns the result of a given amount. So it's a subproblem of coin change. Given the size, current size, I guess you can think of it as current size, or you can just not include this current size at all and consider it as just an amount. Say DFS of a current amount. Say that you want to return not the number of ways, but let me just think. All right, so if you're talking about amounts, get rid of this. 1 plus DFS of total minus coin. Now this would be the summation of all the ways. Maybe I'll call it size. And then result is equal to the min of res and size, maybe. Total is not defined. If amount minus coin is less than or equal to 0, total equals amount. Why am I doing that? If amount equals 0, -1, -1, -1, ways is 0. Zero, 0, nothing. See how we did it here. The result is a big number. Oh. Interesting. I didn't think about it this way. Result here is equal to the min of res and this. And then you return result. No use of size. Size being because when you do it this way, what happens, right? The result always increments. I get that. Okay. This results half of the problem. And then you convert to a DP problem by keeping track of a DP. Do you know your potential domain of the DP? Um, 0, 1, 2, 3, 4, 5, 6, 7. Yeah. At most, it's the amount. So if we set everything to 0 originally, doesn't matter. And amount if amount is equal to, or does not equal to 0, return dp amount, and you would need to also add the result, dp amount result, I think. Give me a second. Give me a second. All right. So list index out of range. Amount. Could it be -1? I gotta check. Wait. What is this amount? It's starting at the first issue. I'm gonna say then it's maybe amount +1. That is lovely. That is absolutely lovely. That is absolutely lovely. Hello, Nahi. Thanks for joining. You caught me at a good time. This is what DP is made for. I understand it. However, that was top-down DP. Let me just look at that solution for that. Top-down DP. Yeah, it's literally that easy as an addition. However, let's try bottom-up DP. All right, so top-down DP. 100% Nahi. Very super satisfying. And we'll try bottom up now. So bottom up requires no DFSs. It requires for I in range of amounts where we start from 0 all the way up to 7 maybe. Do we start from, let's see, instead of doing any of these DFSs, it'll be a DP. And any of these DFSs just becomes DP of the original amount. Let me think. If amount equals 0, return 0. So if DP amount is this, then yeah, you return DP amount. Does not equal to 0, then you return DP amount. But how do you ever get to that point? If the amount is 0, then that's when you update the DP to this new resulting value. Now, there's something missing here. DP amount, DPI, it's the min of DPI. Now we start from 0, but we should probably start from mathinf. Perhaps. What was the problem? This problem is called coin change. So let me try and think about this. So if you have the DP initialized to math negative infinity, infinity means that there is no way you've reached each of the amounts. Now, for when the amount is 0, dp of I is equal to 0. For coin and coins, if amount minus coin is greater than 0, then you would set dpi, but because that's not the case, you don't do anything. But now if you have 1, for coin and coins, for the 1, that is greater than or equal to 0, yes. Then the dp of 1 is equal to the min of math infinity and 1 plus dp amount minus coin. We're just going to take the previous. You're going to take the previous. I break braces 1 minus, so I minus 1. God damn it. DFS is not defined, right? dp. -1, -1. Okay, well. That's my fault. That should still be the same. All right, let's have a look. What is the missing part? So dp amount plus 1. Because you're saying that's the most you can have? And then dp0 is equal to 0. That's fair. The a in range of 1 to the amount plus 1. Amount plus 1. So including 1 to amount plus 1. For C in coins, if amount minus, or in this case, I, I'm going to say amount plus 1. Okay. dp of I and 1 plus amount minus, so I minus C. Fuck. That does make sense. I mean, that's what I had before. Okay, this is a super noob question. I only know HTML, CSS starting JS soon, but what is Leetcode used for? What kind of work is going to require these complex algorithms? Honestly, it's unlikely there'll be use cases. Well, there are use cases, but it's unlikely you're going to do this type of problem solving day to day. You know, the problem solving that is required day to day, probably at a big tech company, is trying to look at errors and then solving them, and then speaking to your co-workers about it. So the only reason, you know, you would do any of this Leetcode problem solving is to really just show to, I guess, the employer, I guess, how dedicated you are if you're talking about big tech stuff. But also, it's a good way to show your logical thinking, and also, like, especially when you're doing the interviews, it's a good way to, if you talk about your problems through with the interviewer, it does show a lot about how you think about questions logically. And Leetcode is just a medium for that. But it's not really likely that you'll do complex algorithms every day. But maybe it'll be part of, say, a design doc if you create one. I'm pretty sure I might be creating one when I'm going to be working at Amazon, possibly. So yeah, it's not used every day, but there are times in which you may need it. Okay, so the bottom-up approach works, and I vaguely understand it. And a breadth-first search approach. Why would you ever want to do a breadth-first search approach? I can understand how you can't make it a space-optimized bottom-up. I can understand that. But in terms of breadth-first search, why is this ever useful? Beyond just thinking about this as a dynamic programming problem. Can't say. Are you focused on software development? Yes. Mainly, like if I'm looking for a, you know, software engineering job. Okay. Okay, so during all these submissions, you know, there have been things that I've done. So I'm going to write these down. So recursive solution, Python. Top-down recursive solution is going to be here. And then the bottom up, top down, not recursive, dynamic programming solution, bottom up dynamic programming solution. This one requires O of t space and not O of 1 because you need random access to the memoized information. All right, memoized information. And so, you know, this is contrary to the previous problem that we solved, decode ways. Okay. And it's worth noting then, this solution is very simple also. Python. So right now you're just trying to get better. I thought most stop Leetcode after getting a job. Yeah, I would say, you know, it's a never-ending process, for me at least, because you never know what opportunities arise and you want to keep your, I guess, skills on tip-top shape when they do arise. And so that's why I continue to do it, but also, you know, there's a level of satisfaction to it as well, which I believe I can stick to. So, yeah. What languages are you good at? The languages that I use mainly are Python. I've used C a lot in the past for school projects. And I've used maybe 2 subjects worth of Java. But I would say I'm not fully proficient in Java. Like I can use it if I want to, but I've only ever used it in school projects. Same thing with C, but I've used it more. But Python, on the other hand, I could use comfortably without any issues. So you could say like I'm mainly a Python user. But I feel like any language, like C, Java, Python, they're all on equal standing. Maybe just Python's a little higher in terms of skill and in terms of comfortability using them. Okay, so now I would say this dpi minus coin is random access and not, yeah, it's random access, okay. New line. New line. New line. Is that right? Is that the only 3 additions? It looks like it. As denoted by, all right, it's 6. I need to get ready to go. All right. And then there is a, I guess, breadth first search solution. I mean, I can just look at this and have a think. Seen times the amount plus 1. If it is seen, next is equal to true. Seen 0 is equal to true. Okay. N times t, where n is the length of the array and t is the given amount. Hold on. I've got to keep track of these times and space complexities as well here. Time complexity O of n to the power of t, where n is the number of, is the length of the array coins, and t is the given amount. Space complexity is O of t. Why? Because the depth of the DFS. BFS. Also, another newbie question, how GitHub works. I don't get why it's so widely used. That's a good question, all right? If you know anything about Git, then you kind of get why people use GitHub. But Git is version control, right? And because people use Git, the place where you host your Git repositories is GitHub. Now, 99% of developers use GitHub, but there are other platforms like GitLab, right? Similar to GitHub, but it's called GitLab. And there's also self-hosted versions like Git, where it's just something that I'm using, Gitty. All right, but regardless, GitHub is one of these hosted repository platforms where you can put your repositories online, right? Online, either privately or publicly, as a backup of your work as version control, right? So Git is version control, but GitHub is where you put all that data for that repository or for that Git repo. All right, with that said, I need to get ready. Let me just write something. So top-down approach, all other time and space complexities henceforth, I don't know why I'm writing so fancy, is time O of n times t and space O of t, where t is the length of the, t is the amount, which makes sense. Time complexity though, n is the length of the array coins, and t is the given, because you try for each, right? So you do like a for loop in a for loop. All right, that makes sense. Think about O n times t as for loop in a for loop, which is the case, which is more apparent in bottom-up DFS. I mean dynamic DP, as seen below. All right. And then, even the breadth first search though, can I be bothered understanding? No, I can't be bothered. At the moment, I can't be bothered. Go ahead, Nahi. Go ahead. That Q is weird though. The result plus equals 1 is even weirder. Don't even know. When do you think you're ready for Leetcode? I've seen a video of this guy suggesting to know combinatorics and number theory for some algebra first. I think like you're ready for Leetcode as soon as you understand basic programming in a certain language. Okay. Because the first ever Leetcode problem that you see in any of like Leetcode 150 is arrays, and arrays is just as much as you need to know when you're starting out. And, you know, hashing, you get an idea of, and you'd have to learn a little bit about hashing on the side. Like when you do Leetcode, you can kind of think of it as like giving you sort of introduction to these other concepts, right? Hashing, arrays, two pointers, sliding window. And with these ideas, you can then look further down into the trees of knowledge which exist there. Now, you said you've seen videos of guys suggesting combinatorics and number theory. That, I don't think you really need much of that at all when you're doing Leetcode problems, right? Maybe later down the line, like, look, I haven't done any of the greedy intervals, math, geometry, and bit manipulation yet. But maybe, you know, math and geometry, that's where you use combinatorics and number theory the most. Maybe. I don't even know yet. Because I've only done zero questions there. So, yeah. And yeah, it was a competitive programming video, to be fair. Yeah, okay. Well, that might explain it. They're a different target audience, I would say. Like me, I'm not a competitive programmer. I can do Leetcode, but I'm not a competitive programmer. So we can learn about data structures and algorithms on the go while solving problems. Exactly. That's what I was telling Moad, who's in our Discord server. He wanted to know like exactly how you would learn about the essay while Leetcode as well. It's literally just do Leetcode, and in the process, when you're doing Leetcode, you'll come across these data structures and algorithms. Learn about these data structures and algorithms until you understand them, really understand them. And then go back to Leetcode again, do more problems. You'll come up, like these concepts will resurface again more often than not if you do like a Leetcode problem every day, every week, or consistently, basically. That's all. All good, Nahi. All right. That's it, guys. I'm gonna get ready for the day, for the night. All right. So I'll catch you guys later. That's finished one question on dynamic programming. We understood the recursive solution, the top-down approach, and then the bottom-up approach, the simplest looking approach. I'm pretty happy with that. And yeah, that's it, guys. Peace.